Hi, and welcome to day 2 of my Typescript Challenges challenge. Yesterday, I had a look at the first challenge, the Hello World challenge, and it was pretty boring. It was just a warm-up, and all we had to do was define a type that matched the string type. And we simply did that by, defining the string type. But that was boring. However, I found these very interesting. The utility types that they were using to check that the type we were defining met the requirements. In this video, I just want to dive deep into the NotAny utility type and walk through it in plain language, just explaining how it works, and also see if there's any other way that we can check the requirement that the type we've defined is not any without using the not any utility type. So let's get cracking. First thing we're going to do is dive into the not any utility type. And the way we're going to do this is just pick at the definition of that type. And this is something I love about TypeScript. If there's any type you want to know more about, you can just pick the definition, copy it out, and play with it, which is exactly what we're going to do. So now that we've copied it out, I'm just going to check that it works as before. We can see that the not any utility type that we've copied out, it's still helping us say that the case expecting the type we defined to be not any is false. And also when we put in the correct value, cool, it's working. It's telling us that it's true that the type we defined is not any. So let's take that as confirmation that the copied out definition works the same. And let's move on to explaining in plain language what exactly is going on with this not any utility type. What exactly is it, and what's it doing? So let's do that. For starters, the not any utility type is a generic type. It's what's called a generic type in TypeScript. And in case that's unfamiliar to you, just think of functions in JavaScript, right? The equivalent of a generic type is functions. And rather than rather than curly braces, well, not curly braces, rather than round braces, we simply use pointy braces. I call them pointy braces. But yeah, so just think of this as the equivalent of a function, and it takes a parameter t. In this case, that parameter is the type hello world, which right now has the value of any, and then it does stuff with that, just like a function would do in the value space. And unlike the value space, I think I should note that all of this get erased when we convert this to JavaScript. But yeah, so it's not exactly the same as a function, but it kind of functions the same in terms of it can take parameters, it can do stuff with those parameters. So yeah, what does it do with the parameter it receives, which in this case is the hello world type? It passes that into another generic type, right, which takes only one parameter. And what does that type do with the parameter? The first thing it does is it looks at the set of the type we've passed in. In this case, it's any, and it runs an intersection of that type on the set of 1. That's important because it allows us to narrow that type, which could potentially be very broad, into one of 3 possible cases: 1, never, or any. Now, the way it does that, I'll explain. Say the type of passed in is 1, or a set or a type that includes 1. When we run an intersection of that set on the set of 1, we're always going to get just 1. So if t is 1, or a set that includes 1, we're going to get 1. So that's one case. The other case is, what if t is not 1 and t doesn't include 1? We're going to get an empty set of never, right? So that's the 2 cases down. And the third case is, what if t is any? If t is any, when we run an intersection of the set any on 1, we're going to get the set any, right? So doing this helps us narrow down T into three possible types of one, never, or any. But obviously, that's not enough to tell us whether the parameter type we've passed in is truly any. So we go a bit, so this goes a bit further by checking if the set that this intersection returns is large enough to be a superset of another literal type 0. Um, Now that's useful because we know that there's only one condition where that will be true, where it will be true that the set that is returned by that intersection is large enough to be a superset of the literal type 0. And that's when we've passed in a parameter type of any. In the other cases where the set that's returned is either 1 or never, those sets will not be large enough to be a superset of 0. So that's enough to tell us when we get true here that the parameter type that we've passed in is any. And if we get false, it tells us that it's one of the other two cases. It's either we passed in a parameter type that included 1 or we passed in a parameter type that didn't include 1. So that's how this works. I'm just going to jump over to Excalibur to explain that visually. What we have initially is a set 1, and we have a set that could be something that includes 1, something that doesn't include 1, say that's 2, and something that's any, right? When we run an intersection of the sets 1 and 1, what we will get is 1. When we run an intersection of the set something that doesn't include 1 and 1, what we get is never. And when we run an intersection of any and 1, what we'll get is any, right? But that's still not enough to tell us where we are. So that goes a bit further and runs an intersection of the set 0 and the set 1, the set 0 and the set never, the set 0 and the set any. Basically checking whether 0 is a subset of 1. In this case, this will always be false. In this case, this will always be false. But in this case, this will always be true. So when we do that subset check and we get true, that tells us that we got given a value that was any. So that's basically what's going on there. And yeah, when all that's done, we go back, execution basically goes back here, and the whole point of this is to invert that boolean, right? From a truthy value to a falsy value, or from a falsy value to a truthy value, so that it's just easier to write out without using the equality statement here. And I'll try to explain what that means. If the value we passed in is any, then this returns true. But when checking whether the value we passed in is not any, we don't want to return true. We want to return false. So what this does is it takes that true, and if true is a subset of that true, then we return false. Otherwise, we return true, effectively giving us the inverse of the is any check. Right, so I hope that explains what was going on with the not any generic type acting as a utility type in plain language. And the last thing I want to do is show that we can work without not any and achieve the same results. So using is any alone, we can set up a test case to check that the type we're defining here is not any. And we're going to do that by borrowing the utility types used here and the syntax used here. So let's just copy that over and let's add a comma. And the first thing we want to do is check whether the type we've passed in is any. So let's extend that to check whether the type we've passed in is any. And obviously that takes a single parameter. So that's what's happening there, taking a single parameter. But right now it's checking whether the value returned by the check, by the generic type is any, is string, but instead we want to check that that value is false, that the parameter type we're defining is not any. So cool. So without using NotAny, we have written out the same check, and we're going to see if it performs the same, right? Clearly, it's performing the same in the falsy case, but does it perform the same in the truthy case? So it does. So that shows that we don't need this if we choose not to use it. And I think that demonstrates that we truly do understand what's going on here. And perhaps the only reason NotAny utility type was created was just because the authors felt, they could they could save themselves keep a few keyboard strokes by shortening this to the NotAny utility type. Yeah, so I hope that, that was a good deep dive into the NotAny utility type, and that the plain English explanation actually helps explain what's going on with a utility type, and I hope this adequately demonstrated how we could do away with that NotAny utility type.